Hey again guys, and welcome back. Today I've got a bunch of stuff. And the reason for that is because it's time to make my 110 volt, so wall power here in North America, test setup. So let's get all this stuff out on the table so we can see it all, and I'll tell you what my plan is. Most of this stuff was bought off Amazon. Some of it comes from the local Orange hardware store. Okay. If it came from Amazon, that's because it's actually cheaper there than my local hardware store. And some of the things aren't available at my local hardware store. Well, let's see what all this stuff is. So first of all, I've got an electrical box. Now this is a insulated, it's supposed to be airproof and draft proof or whatever. That's why it has this. But this is a standard electrical box, a double gang for North America. And if you'll see, the only metal that's inside is these two green tinted screws. And they come up to here, and we'll see why in a minute, but that's the ground. Okay, and this has no holes and nothing that sticks out aside from the ground lugs, which I can put insulation over, because just in case, plastic is better. I know that the metal boxes are grounded, but it doesn't matter. I wanted plastic, so here's plastic. I have here a cover. This is a standard 2-gang wall plate cover. So it should go line up with these exactly, and they do. So one is blocked off and one has a hole for a device. That device is this guy here. This guy came with its own plate. And this is a GFCI outlet. So that will go in here. It'll go on top of... It'll go in the box here, and then the cover should fit on top of that. I know the colors are mixed matched, but white's pretty nice because I get to paint it and color it whatever, however I like. So for the wires coming in, typically you push in these tabs here, and you push the wires in through there, and they can't come back because of the way the tab is made. But instead, I wanted to add a fuse. So GFCI is pretty safe because it monitors live and neutral, and whatever comes into one and doesn't come through the other one, I think you can only get about 20 milliamps or 2 milliamps, I don't remember, and then it trips. So this is why I want to use a GFCI for that, but there's no fuse. The fuse would be like in your wall, like your breaker. So I got this guy, which is it takes a standard IEC cable. You probably have tons of those cables from your computer. Your computer uses IEC, and it has a fuse in here. Now I'm not sure what size fuse. I think that's 15 amps, so that's way too high. So we'll replace that with something smaller. I have some 5 amps here, but I think I would like even smaller, so I might order some 1 amp fuses. And what's great about this is the wall cable will come in here. This is the ground, so I can go directly from here to my back plane here, and I can also wire up a ground here. So I mean, either way, this is all connected, so that's good. So I can put it on this lug or put it back there, it doesn't matter. Then you have your live and neutral. So live and neutral are gonna come in this way, and actually it comes in here, sorry, and they're both gonna be over here and switched. Okay, so the neutral will come over to one side of the switch, out the other, and the live will come from here, which is actually through the fuse, this portion here. So here, through the fuse, through the switch, and then I can connect this up to my device here. So that means that not only do I have this switch, but I have a fuse, and I also have my GFCI. So right now it's sounding safer and safer. Then we have this device. And this device is a foot switch, a foot pedal. And the plan is to break the live after the fuse and before this device here, and get this on the floor so that I can have this as a disconnect, the fuse as a disconnect, this is a safety device, and then I have this totally insulated pedal as my another safety device. So this is completely plastic except for this pin, but it shouldn't come anywhere near the rest of it, and therefore I should now be safe between all these things. I mean, safe enough, right? You can't get that safe. You can't be entirely 100%. You still need to use your brain a little bit. But the point is, this is as safe as I could think to make it. So this wire here, actually, I'm thinking of changing it out and having 2 conductor wire going into here instead of 3 conductor, and using this 3 conductor as a connection. So then I can put my wires on the GFCI, and these connections here that are covered will actually be protected by the GFCI if I want to just put some wires to come through. So basically this is as safe as I could potentially make it. So let me clear this stuff off and let me just show you what the plan is in a diagram. So just to make it a little bit clearer, so here, okay, this is my IEC. So that's this connector here, right there, that guy. And we're going to do ground, neutral, and live. And this will go directly from the IEC. The ground will just keep going. The neutral will head towards a switch, and the live will head towards that same switch but on a completely different circuit. Okay, these two are linked together. It's a dual pole switch. Okay. From there, the live goes through a fuse. The neutral continues and the ground continues. And then over here, I'll have my GFCI device. Okay. GFCI device is there. The live will then come down this way to a foot switch. Okay. So foot switch. And then back into my enclosure. And then L and G. Ground will go directly there. And neutral will go directly there. And then on this side, G and L, this stuff will go out to whatever I'm going to be testing. Okay, so that's basically the deal. So the live, the dangerous one, if you will, is switched by the IEC, so nothing happens even if I accidentally step on the switch. Nothing will be live until I flip the switch. So that'll switch both these, but the ground will still be active, which is fantastic. Then the live, even if it's switched, it's still going to be going through this fuse, which will be as low as possible. It's 5 amp for now, and it'll be 1 amp if I order some more. And then it'll still go to a foot switch and through the GFCI and then to the load. So I think there's several fudge factors in here. I think we're going to be good. So the first thing we need to do, I think at least, is to fit this IEC connector into the side of this box. So let me get set up for that and I'll bring you back. So as always in my videos, I will show you the way I'm doing it, and it may not be the best way to do it, but it doesn't matter because that's how I'm doing it. So here's my IEC device, and I need to put this in here, but facing the other way, mind you. And I picked this side because I think whatever these are for like screwing or hammering into studs. I think I might use that to hang it off the side of the bench or do whatever. So I kind of want this on this side and my device under test on this side. So if the IAC comes in here, I want my device on there. So the way I'm going to do this, there are some CAD drawings available for these to help you cut it out, but how reliable that is, I don't know. Basically, my plan is to measure this out and then cut it out. Oh, it's in inches. Shouldn't be in inches. And then cut it out with the little handsaw you saw before. So it's 47 and a half. We'll go 47.6 millimeters because we want a little bit of fudge factor here. So 47.6 in this direction. So here's what I'm going to do. I'm going to grab this piece of paper, fold it in half. Okay, we need to know what half of 47.6 is, which is 23.8. I don't know if you can see that. So we're going to go down here to 23.8. Okay, and my fold side is over here. So I'm going to take this and just give that a bit of a score. Okay, so there's just a little indentation in the paper. Then I need to know the width. The width is roughly 27. So I'm going to take this at 27 and give this a score. So now I should have a rough outline like this, sort of like this, sort of like this. There we go. Now I can cut this out like so. And again, we're looking for close enough here because the plastic flange is quite a bit bigger than the actual socket. Okay, cut this out like this. All right, open it up now and see if it actually fits. Yeah, it seems like that'll fit, so that's good. Take this off again. Then I grab my box and I can cut the excess as well. Okay, get that centered up approximately, like so. Then take a marker and mark it out. And so that there is our approximate shape. Now I can use a step drill, which I have here, and okay, and again, it's okay if I go a little large. It's okay if I go a little too big, because the flange is quite a bit bigger, and see that one could go a little bit closer here. That one's almost perfect. And then I can keep going all the way around The ones that I'm too far away, I can actually modify with a bigger drill bit. Oh, that's not necessary there. Go over here. Okay. And then I got this keyhole saw exactly for this purpose. Kind of always wanted one, so that was a good timing. Basically, this is a hacksaw, which is hand operated. Where my workbench is in my basement, I don't have a lot of... I can't make a lot of dust. There we go. So I figured this would be perfect to go in here. That might be the wrong size. You can use a Dremel. I have to make little to no dust down here. Okay, so that's very roughly cut. Let's just see where we need to adjust. Look at that. Don't need to adjust anything. So that fits in there, just like that. Then we just have to drill these little holes here, which we can use a marker to mark out. There we go. Get a 3mm drill bit, or I could just hit it like this. Go a little bit bigger than we need. Okay, just like that. Then I just need to clean this out and we can keep on going. If you're a perfectionist, you can do a better job at cleaning this stuff out than I did, but that's not too bad. And plus, I need to get this video rolling along. I don't know if you've noticed, but I've been putting out a lot of videos recently. So, yeah. So on is usually the 1. So I want the 1 facing up. So that's why I'm going to put it in this way. So that goes through here, no problem. That should fit through there, because it did before. Or did it? I guess it went in the other way. This is actually pretty tight now. Yeah, it fits. There we go. And now I can put my little... I found these little screws in my kits of stuff, and they fit perfectly in here. And they're actually recessed. They're a flush mount. There we go. Before we tighten that up and get the other one on, that one could be a bit more of a challenge to get on there from underneath. Didn't really think about that, leaving this so close to the inside here. How the heck am I going to get this on? I've had similar problems in my automotive profession. Well, maybe just 1 screw for now then. It's not the end of the world, because again, yeah, I really do want to get it on there. Let me fiddle with this for a little bit. By some stroke of luck, I managed to hold it by these offset pliers, and get in there and screw it in. So now this is never coming off. Oh well. So now I've got these 5 amp fuses to replace the 15 amp fuse, which is way too high. And in fact, this 5 amp fuse will probably be too high for what I'm doing too. So that can go back inside of here. There we go. So that's good. Now, for the foot switch. I'm not sure if this foot switch will allow me to easily connect up a different wire than this. So we have to open it up to see what's going on in there. So I assume this is just a jam screw, and then you push this pin through, and it certainly feels that way. Oh. There we go. Okay, what do we have here? So the wires look soldered on, which is really not what I wanted. But I can make it work. So remove this. And remove this. Okay, here's the switch. Okay, so here we have a common, normally open and normally closed position. Very good. If I take this strain relief off and turn on my soldering iron, should be able to desolder this wire. Actually, you know what? I'm probably just going to snip it now that I think about it, because I can just solder some new wire on, which I'm planning on doing. There we go. And pull this 3-conductor wire out. And the reason I don't want to use a 3-conductor in here is because I don't have any 3-conductor to make my test setup out of. So I figured I would just use the wire that comes with this, because it's 3-conductor, and replace it with some 2-conductor in here, because that's all I need. If you remember the diagram, only the line is actually going to come down to the switch, the foot switch, and back up. So it's only necessary to get 2-conductor. And I have some of this 2-conductor here. This one is from a neighbor's vacuum cleaner. So he was throwing it out, and I figured instead of letting the truck pick up the garbage truck pick up the whole vacuum cleaner, which was clearly broken, I would just take the cord off of it and it can be reused. The vacuum is double insulated, so it only has the 2 conductors, the live and the neutral here, although we're not going to use them as live and neutral, and therefore will be good enough for the switch, but not good enough to go from the GFCI outwards. So strip some of this off. 1 and 2. I still don't have a wire stripper, by the way, guys. So again, I'm still looking for suggestions. So if you have suggestions on which one I should get, let me know. So normally open is down here. I'm going to turn on the soldering iron. And now it really doesn't matter which one is which. It'll only matter once I bring it back up into the box here. So really I could solder this to any of these connections, but one needs to be on the common and one needs to be on the normally open connection. So actually I should probably run this through first, like so, while I'm waiting for the soldering iron anyway. Okay, so again, the common seems to be down here, and the normally open is this guy here. Put some fresh solder on here. There we go. Put some fresh solder on here as well. Give this a chance to all get melty. There we go. And then we're going to go, the common will be black. There we go. And then the normally open contact. Boy, that wicked a lot of solder. Yeah, that may have hardened a bit much. We'll see. This is a tester for non-continuous use, so it's not too bad. That is a bit sketchy. Oh, it's getting hot. Not too much mechanical holding there. I'm not exactly proud of that joint, but I'm having a hard time holding it together. Oh yeah, that was a bad joint actually, if you look at it. I need to anchor this somehow. I need to anchor this and solder to it at the same time. Let's see. I think I got it now. Let's see. Might go better if we add a little bit of flux. I inadvertently soldered it together. Would you look at that? I think at this point it would have been better to use crimp terminals, but my problem with crimp terminals is that it's tight in there. I have no doubt that that is soldered, but I'm not too happy with it. So maybe I'll see how it fits and maybe we can insulate it a little. But other than that, might have to call that an attempt. I'm not really happy with that. The wire is getting hot though. Let's see how it sits. You know what? I'm just going to desolder this and start all over. Okay, let's try this again. So the switch now is down to bare metal again. And I'm going to do the same thing here, just cut the insulation back. There we go. I find it funny how these power cords literally have cord inside, like rope. Okay, and it's cut. Now I'm just going to take a little bit more off than I did before. This feels like surprisingly high quality cable. I think now this time, because it was so hard to bend the cable into where it needs to go and hold it and solder it, I'm just going to feed the wire through like so. Grab it on the other side with a pair of tweezers or pliers, like so, and yank her through. There we go. That's a bit more messy than I wanted, but at least it'll solder up nicely. Okay, same thing with this guy. Pull it through here and twist it around like that. And there we go. So now it has a little bit of mechanical hold, and we want to solder it kind of this way. So it has a little bit of mechanical hold and should be able to solder it together. See, again this split on me. I know I'm not doing this right, guys. I completely know. I'm kinda trying to get this done quick. And some of you will chastise me for that, but you know what? So be it. Learn from my mistakes. So I'm going to put the heat to her. Let it heat soak a little bit. Okay, pull it out, and now it should harden. And we can do the same thing for the other cable. Probably still need the helping hands. that should do it. I hope so, at least. Yeah, couple flying strands, but not the end of the world. That's good. They're well separated, right? They're not ever going to come into contact with each other, which is kind of the point. And then we can set this down like so, the wire coming off to the side. And I do believe it was these short guys that goes into here. It does seem like you should be able to slide it over, but it's in practice it's a little bit harder than that. Need to get a really good magnetizer. That's one thing I don't have. A magnetizer slash demagnetizer. Okay, I need to make sure this cable is kind of out of the way. Yeah, should sit flat. Put the cable clamp in its place. Trying to do this on camera too. It's hard to keep this in frame. Sorry if I left the frame a little bit. There we go. So that should work. And I'm pretty confident that I didn't ruin the switch. I'm so confident, in fact, I think I'm going to close it up and test the wires after. Alright, so I need the spring. Oh, the small end goes down, big end goes up. This might be a little tricky to get back together. A little trickier than I expected. Hold it together. Pop this thing in, and then the little screw in the middle to lock it. That should be us. Okay, so this is live here, and by live I mean one take. This is a lot of, I didn't realize how much cable I actually took from that vacuum cleaner. Alright, so these two ends are separate, but when I click the switch, they should have continuity. So here we go. Put the buzzer on. Buzzer is on. Connect this to one of the leads. And this guy. So if I touch the lead itself, the crock clip beeps. I don't know if you can hear that. At least you can see the meter here. I think. See, it says OL. I just touch the crock clip. Okay. So if I touch here, it should not make noise. Okay. So that's OL. Perfect. Now if I click this and touch here, there we go. So this is working as intended. Now I don't need a buttload of cable like so. I just need actually quite a bit less. I need enough for this to go on the floor, and for the rest of this to reach up on the bench. So probably I'll give myself a little bit extra. I'll cut it here. the rest of this becomes some nice 2-conductor wire that I can use for something else. Here is the end of my switch, and now I need to bring this wire into this box. So I think the best place to do that would be here. So let's see what happens if I just shove this in like this. I think you're supposed to poke a hole, but you know, I think I can turn off my soldering iron now. Okay, so now I can grab this and pull some in. And yeah, I can't pull that back out. So this is actually a very nice system. This box was about $6 locally. Alright, so let's cut some insulation. So we want to take enough off that we can work with this. So probably, I don't know, down here. The excess wire can always be stuffed into the box. There's going to be a lot of extra space in here. Okay, looks like I'm at the cord all the way around. Pull that out. Ooh, very nice. Look at how it's twisted like that. If anyone knows what the purpose of this cord is, if it's just, I think it's just for structural strength. So you can pull on it, because this was a twisty cord thing. If you know what it's for, let me know. So I think I can pull the rest back out after. But let's strip some of this wire. So like maybe up here. Oh, missed a chunk. And if you're worried about me testing bigger loads, well, the fact is this switch is normally open. So it's not like I can walk away from it. So whatever happens, it'll happen in front of me, which means I can react to it. I have a fire extinguisher not too far. I can unplug the IEC, I can flip the switch. There's a lot of things I can do to protect myself, so don't worry too much about that. Okay, so now, actually I probably shouldn't have cut that long. So any one of, like this red wire here, needs to be cut because I'm interrupting that. So if you look here, that live is that red wire. It's coming across here and it's getting interrupted. So I will strip this. Okay, and then I will twist this one around like that. Okay, and now I could solder this, but I have another solution for this. So that one's done. Same thing here. Maybe I'll go a little bit bigger. No, I'll go short. I need to go short. Oops, pull it right off the IEC. Which is fine. That, wrap it around like that. Okay. Now I'm gonna crimp this. So let me get my crimpers and I'll be right back. Back now, and this is my connectors bin. And I'm looking for some crimp-on connectors. Definitely seen them not too long ago. Where did they go? Oh, they're right here. I'm just blind. So you see these inside of actually a lot of products. It's not really they're not designed to be put inside of these electrical boxes, but they should work just the same. They go into a crimper like this. In fact, this is probably not the correct one, but it does do the job. So I give it a crimp like that. So these wires are now inseparable, and the resistance of the crimp or of the connection here has been reduced because they've been squashed together so hard. Now, the important part here to know is that you need a crimping tool to do this. The generic, like automotive ones, will often damage the sheathing, and you definitely don't want to do that. And also, you want to make sure that there's no copper exposed on the other side there. And again, well, same notice as before. I'm not exactly an expert. I just know a few things about a few things, and I know that this should work, but there is a chance that that is not proper. So if that's the case, you probably shouldn't do this for yourself. If you're not willing to take the risk and have, be nearby all the time while you're doing this, it's probably not for you. But okay, we've got our two connections here now. I can tuck this out of the way because we don't need this one anymore. It goes down to the switch and back, so we only need this. So now we're at the point where we need to wire up our GFCI outlet. So our GFCI, technically, if this cable's coming out of the bottom, this is down, you're supposed to actually mount them this way with the connector in a way that doesn't look like a human face. Because, this way it really does look like a face, but yeah, I think for simplicity's sake I'll go this way. So we've got live and neutral. So here is hot, which is black, and in our case it is this spade terminal here. I haven't checked this. I hope yes, it does fit. Good. So really, this is pretty low effort now. More like doing Lego sets. Just make sure this is nice and tight, and that should be good. Next one is the neutral, which is this blue wire on our IAC connector. I'm really happy these spade terminals fit. You can just put the wire in here though. You don't need a spade terminal or a fork terminal, but it makes everything so much cleaner. I mean, look how nice that looks. And then here is our ground. Ground goes here. Usually ground is green colored in Canada. And I'm not too worried about this not being connected to these grounds because it will be bolted up right here. So that should be just fine. Make sure that's tight. That's good. And kind of fit this all in wherever it fits. So like that. Now I need to find the screws that came with this GFCI plug. Like so. So it's the long ones that go into these holes here. Don't ask me why. That's just how it is. So this one will be a kind of a pain in the butt to screw in because it has that metal shielding. And then I'll put this one in. And you'll notice there's threaded holes just on top, and that is for the plate. These are cool screws too. They have a Phillips, a Robertson, and a flat. So if you Americans don't know anything about these Robertson, these square drives, they're so much better than Phillips. I just don't know if I have the right size. I think the red one is the most common, red Robertson. There we go. See how much less play there is in that? Okay, sort of want to center it up here. The centering doesn't matter too much because, as far as I know, the wall plate doesn't hook on to anything here. It just takes these holes here, and because this side here is blank, you see the holes are further down, so they actually fit directly into there. Okay, so this plate should fit on top neatly like that, and it does. Now I've got my screws. And there we go. That's it. This should be completely ready to go. A few little notes that I forgot to mention. These are tamper resistant sockets, so it's really difficult to shove something in there. So if I'm working on something and it falls in, it should be okay. I should be able to just turn around and shake it out. And also, this thing has a red neon indicator letting you know that it is on. So yeah, this is ready to test. Question is, are you guys ready to test it with me? Looks like shoving that screw in there kind of pushed the whole thing up and away. So I might have to open this up and take a look at it after. Either that or it's just made crooked normally. Oh, it is a bit crooked. Okay, it's crooked because there's no other device in here. That's interesting. But anyways, here I have an IEC cable, and I will gladly plug this in. Also, I'll take this light that's over here and plug it into here so we can see if it is working or not. So here it goes. Watch the light level. There it fell. So we'll take this over here, and now I can plug it into here, and it should not light up, and it does not because there's nothing there. Now I take this IEC cable and I plug it. Okay, nothing has exploded, which is great. My switch here is off. I will turn it on. See, at no time here am I touching anything that is metal. And if I shade this, I don't know if you can see. No, you can't, but it is lit, telling me that there's power. At least there's power to the IEC. But your light's still not on because I'm still not on the foot switch. So now, if I actuate the foot switch, this light here should turn on. So let's see. And it did not. Interesting. It looks like the GFCI tripped. That little LED comes on. What happens if I... Very interesting. Maybe if I hit the test. Oh. I can't even test it. That's odd. It should be working. I don't see why it shouldn't be working. This is interesting, actually. Why does that light turn on? Yeah, it turns on even with this unplugged. Okay, let me open this up and I'll bring you back. Well, it was something incredibly stupid. So it ruined my moment, but what had happened is the test switch came from the factory pressed in, and I couldn't reset it because you have to reset it while the power is on. So basically, this does work. There's nothing wrong with it. It's just I had to hold down the pedal and then press the reset here. So if you look, if I go test, it blew. If I let go of the pedal and try to reset it, it won't reset. You need to activate it so that little blue light's on, and then hit the reset, and now the light comes on. So it ruined my moment, but at least this is well done. Let me put this back together. So there you have it, a relatively safe way to test 110 volt devices completely hands-free. So I really don't think you should do this at home, but if you do end up doing it from your own volition, not my responsibility, and it ends up really well, let me know how it went and let me know how you built yours and what you would do differently. And other than that, I guess now you can expect in the future I'm going to have a couple of high voltage, 110, 120 volt projects on the way. Thank you so much for watching. The reason I built this thing is because you guys cared and you guys wanted to see it. So if ever you have suggestions for the channel, make sure you put them in the description below. I hope to see you in the next one.